A Latin square design is considered a three-factor design, which refers to the factors being equal to each other, consisting of the rows, the columns, and the n unique data sets. As a result, this creates an n by n grid populated with n distinct values, each appearing exactly once in each row and each column. It is best utilized when researchers wish to control the variations in an experiment. Latin squares are typically used to balance the possible treatments in an experiment while preventing mixing up the results with other treatments. An advantage of using this is that it is capable of handling cases when there are several nuance factors, especially when the values cannot be combined into a single factor or we wish to keep them separate. In addition, Latin squares allow for relatively small runs. On the other hand, the disadvantages are that the number of blocking variables must be equal to the number of levels of treatment factors, while assuming there is no interaction with the two factors. We are capable of doing simple analysis by utilizing the general ANOVA, or analysis of variance tables. This presents the sum of squares used to calculate the mean of squares, degree of freedom, and F ratio for the various sources of variation, including the rows, the columns, treatments, and errors, which analyzes the experiment with a single factor with constraints on randomization or randomized blocks, just like the Latin square design. The P within this table refers to n, since the Latin square is an n by n square. So, for example, the degree of freedom for the rows, columns, and treatments of a 4 by 4 grid would be 3. Presenting the sum of the rows, columns, and treatments allow the researcher to get a general idea of how the data is affected by the treatment and errors that occur. Conclusions can be drawn from the sum of squares of the total and the total degree of freedom. So I provide code written in C++ that would present a Latin square. I thought this would be an interesting engineering-related implementation to present how it could be utilized in a computer environment. So I would input n, which is set here in the main function, and call the print Latin function, and as output you would get an n by n grid. So if I inserted 6 as input, a 6 by 6 grid Latin square chart would be created as a result. By creating a combination of loops, we are able to create a matrix-style output while keeping into consideration the restrictions of the Latin square design, where the first iteration starts with the first row, and then the next loop would be creating the columns for that specific row. Once n columns are created, then it goes to the second iteration for the next row and repeats the process for the columns of row 2. This process repeats until n rows are created, while considering each row and column to not repeat any values.